give a few more minutes for folks to sort of trickle in because it is so short. We don't want to waste too much time. So I want to, some of you may have attended one of our previous show and tells, and I want to just give a quick intro of Synchro. So I'm Amy West. I'm a program manager from Synchro, and here with me is my colleague Jason Adelars, our technical manager, and our guest speaker today from Oshen, Anita, zooming in from Plymouth, England. Before I hand the reins over to her to talk about some pretty exciting work collecting data autonomously in some interesting ocean conditions, I want to explain why we're having these webinars. Synchro is sort of a conglomeration of marine institutions. We're based here at Mbari, but we have a lot of goals. And one of those is to sync the development of emerging ocean technology with the needs of marine folks, such as those who use the information collected by those tools. But those users don't always get a lot of attention. So this series is helping kind of bridge that connection because developers want to design something that's, you know, incorporating user needs. And that's often harder than it sounds. So just a little bit of housekeeping. We'll jump right into it. If you have any questions, please put them in the Q&A because we'll address them in the last 10, 15 minutes. And with that, I'll hand it over to Anita.
All right, awesome. Am I good to start sharing my screen?
Yeah, go for it.
Cool, okay, so this one, share, and this. Okay, let me know if you guys can all see that okay. Yes, okay, perfect. All right, so hi everyone. I'm Anita, I'm the CEO and co-founder of Oshen. In this kind of very quick webinar, I'm going to go over 3 different things. Number one, kind of like what Oshen does and what our purpose is. Sorry, I know there's sea stars kind of like zooming in and back. It kind of looks like it's at sea, which is cute, but I'll shift a little bit so the background's clean. The second thing I wanted to go through is like the history of Oshen and a little bit about how we came out, and especially kind of how Synchro fit into that and what the benefit was for us and how it like really helped catalyze things. And then the kind of final part is very new. It's some very exciting work we've been doing in severe weather, literally last weekend. So kicking off with kind of what the purpose of Oshen is, what's the problem that we're actually trying to solve? The core problem we're trying to solve is wide area persistent ocean data coverage. Essentially, we believe that the oceans need and would benefit from a wide area persistent monitoring network. Now, that sounds like super lofty and high level. So to break down a little bit what I mean by this is that, you know, there are already multiple really impressive parts of our ocean observing network. There are, you know, things like moored buoys, which provide data in a really precise location, but they don't do so they're persistent, but they don't do the wide area aspect. There are things like drifting buoys, which can cover a wide area because they're so cheap, you can get many of them out there, but you can't control where they are. So they're not persistent in getting data in the right place at the right time. So what we thought would be beneficial as a new component of ocean observing systems, a new kind of tool in the toolbox, is something that's low cost, able to stay out at sea for months at a time. But because it's low cost, you can kind of put, let's say, 100 of them out there and cover a wide area. And this is the kind of founding thesis that Oshen kind of started with, and that's what we hope to solve. So a little bit about the system and kind of the overall thing that we do as a company, the solution. So we make and deploy constellations of sea stars, and each sea star is what you see there. It's a small 1-meter autonomous surface vessel or robot. And for the scientists who are familiar with other ways of collecting ocean data, for example, the easiest way to think of this thing is as a controllable buoy, or buoy, if most of you guys are American listening in. Key things to think about: it's easy to deploy. We've kind of made sure they're a meter so that, you know, you don't need equipment to deploy it. So that means folks don't need ships with expensive cranes to get it out there. You can just chuck it overboard. And then it's sufficiently navigable that, let's say you deploy it from land or like, you know, 1 mile offshore, it can then navigate really far out to a specific location and then station keep as required. For propulsion, we use wind as our primary method of propulsion, and a combination of battery and solar to power the onboard sensor. And a thruster we use for short sprints, and that's a really interesting point because synchro get a mention in there, which I'll talk about later. Quickly discussing the sea star itself, so going down from the constellation of sea stars to the individual unit. A couple things that I thought folks would be interested in. So first off, in terms of the autonomy and what that looks like, the sea star runs on software that we at Oshen have written. It's quite custom to the sea star because it needs the wind to propel itself. And essentially what the user does is it sends it kind of individual waypoints or station keeping commands, and the rest is actually worked out on board the sea star itself. In terms of the sensor payload, the two primary kind of sensors that we have done to date is meta-ocean data collection, so wind, pressure, sea surface temperature, that sort of thing. And then also passive acoustics, for example, for listening to the underwater soundscape, listening to presence or absence of bottlenose dolphins, for example. And then we also have an onboard camera, and we've had a look at kind of taking things further from there. Data pipeline, we communicate via Iridium short burst data, and we use one level up on the kind of scale of data packets if we need to send, for example, images back. Going to operating range, so I now need to go and upgrade this in terms of we've survived more than storms now. But the two kind of things you need to do to stay out at sea for a long time is show that you have endurance and also show that you can go through the kind of severe weather that you'll have if you're at sea for a long period. We've now done, many sea stars have done missions for over 1 month continuously now, and we've also had sea stars survive hurricanes. So that was part one, essentially explaining about the system, the constellations of sea stars, and then the individual platform and the sense payload. Now, this kind of part two essentially explains a little bit about the company's history and where we've actually come from. So I have one slide per year plus an extra slide for synchro, so it's going to feel like I'm moving quickly just because of the time constraint. So 2021, that's when Oshen kind of the first concept started to come about. I was studying aerospace engineering, wanted to marry that with my kind of love of sailing. I was building kind of small autonomous boats to compete in a challenged cross-Atlantic Ocean. In the process, realized that ocean data pretty difficult to access, and that, like, you know, I just felt like the world would benefit from these kind of like loads of kind of small monitoring platforms, as opposed to where a lot of the industry was going with these really large, exquisite ASVs. So that essentially led to the starting of Oshen. Really early company days, we didn't want to take venture capital. We didn't want to go the traditional route. So myself and my co-founder, Kieran, purchased and lived on a sailboat for 2 years. We used it as our test platform as well, going out, chucking the sea stars overboard. This allowed us to kind of do a lot of testing, going out to sea all the time on the cheap, and allowed us to develop the core technology. 2023, that's when we focused on really refining it. So the sea stars no longer would break at sea, you know, in terms of water ingress or something. So that's when we needed to sort out the software, make sure that they were able to sail upwind, maybe make sure they were able to navigate to a waypoint. And this is kind of when we started to engage with synchro. You know, we kind of had a rough idea of the market applications. The sea stars were kind of working, but we had no customers at that point. And, you know, this is the kind of like awkward, maybe valley of death that many startups find themselves in. So what we did kind of under the synchro program was we sent a sea star out to Monterey Bay. What we had at the time is our newest, most up-to-date version of sea star. We ran a training course over there, and we got a lot of really valuable feedback on kind of what information someone who's using the sea star, who's not internal to Oshen, does and doesn't need to know. That was really helpful to have someone else use the mission planner, for example. And then we deployed the sea star, had it kind of do some operations out in Monterey Bay, and had a lot of lessons learned from that. And just, you know, if anyone in the audience is thinking about that kind of stage of product development, just a couple quite interesting learnings from this. Like, number one, you know, as a startup, you think you know everything, you think you know exactly what like your customers want. And I remember, like, you know, day one we turned up and someone told us, oh, you know, you should probably have a thruster on there just in case there's light winds. And we said, oh no, don't worry, our boats navigate really well, you just don't need a thruster. And then turns out you have really light winds in Monterey Bay and also rather strong currents. And we absolutely did need a thruster. So like 3 months later, we had to go back out with a retrofitted thruster to put on to kind of enable a more successful mission. And now the recent generation of 15 sea stars we made, they all have like inbuilt thrusters designed into it. And it was like quite a useful bit of feedback to have gotten basically a year earlier than we otherwise would have. And there's a lot of kind of little bits like that on the mission planner, for example, or like taking into account the currents a little bit more, or just understanding that like just because your product works really well in one bit of the world where it's super windy, like doesn't mean that it's going to work great in another random bit of the world. So it was a very useful program, and a lot of the feedback from having external people like using it who aren't like all the way there to full customers, that kind of solved a kind of key bit of the customer kind of product journey. Fast forward just over a year now to present day. So where we are as a company, we are deploying 50 sea stars under a project with ARIA in the UK for monitoring of climate tipping points. We have a contract with NOAA that's live now with 7 sea stars out off the coast of the US and in the kind of off the Caribbean for hurricane data collection. And we're doing a lot of like really promising stuff that's come out of that early feedback. So speaking of which, here is a map of all of the places sea stars have been deployed previously. So green and yellow triangles are where we've previously done missions. And then the red ones is just things that are happening in the next 6 months. So over there on the far left there, you can see the mission that we did under the Synchro program. The 50 sea stars that I mentioned in the North Atlantic, just for people that are interested, the data is being collected up there. And it's just worth noting, because that project is specifically for science, it's for climate tipping point monitoring, we are allowed to share the data from that with like anyone that's kind of either like related to the UK or US governments, or who's kind of like doing work on science or climate change monitoring, that sort of thing. So if there's anyone interested in that data, we're allowed to share it for free, and we want it to kind of do maximum good. So please contact me if you want to use it when we deploy that constellation. Now, finally, to some of the most fun stuff, and this is the first time I presented this because it just happened on the weekend. So these were the 7 sea stars that we had out for NOAA this hurricane season. They were those 5 down there, especially, they were essentially in a picket line, all 100 miles apart, kind of sat there waiting for a hurricane. And then as the forecast changed, what would happen is the NOAA science team would kind of page us and say, send the sea stars here, and they would all make a beeline towards where the kind of best guess of the hurricane track was. And the objective of this was to collect data on air-sea fluxes, with the idea that, you know, that can help operational forecasting kind of right now this year, but in the long term as well, hopefully better understand hurricanes and how they intensify to hopefully kind of predict these really important events better in the future. So this is kind of what happened over the weekend. We had Hurricane Humberto kind of coming over, and we were able to have 3 sea stars, PC2, PC3, and PC8, all lined up ready to intercept her. And it's Category 5 hurricane. So some very exciting outcomes. The first one is that because it was a Category 5 hurricane and we were able to actually, each sea star individually provided data for about 4 hours each, Oshen sea stars are now the first USVs to successfully intercept a Cat 5 hurricane eyewall and provide data from a Cat 5 hurricane, which is really fantastic to have and to kind of know the robustness of the platform. Just a rough idea of the conditions, the gusts, when you adjust them to the 10-meter NHC height, went to over 140 knots. The 2 sea stars, I'll just quickly show you, those 2 up there, they were rapidly deployed by the University of Southern Mississippi ahead of Hurricane Imelda, actually, when it was forecast to make landfall. And the concept that we were testing there is, let's say there's an event that you want to find out about that's evolving, so a marine heat wave, or just anytime you might want reactively to flood an area with ocean observations. Because sea stars can fit in the back of a truck and then you just chuck them overboard by hand, they were able to get 2 sea stars really quickly in the water to assess what was going on and to help provide data in case Hurricane Imelda had made landfall. And final thing, the kind of really nice thing in terms of actually, you know, all very well to collect data, but you need it to be useful. was that the National Hurricane Center referred to the Oshen sea star data in their forecast discussion. And, they were looking at the dashboard throughout the whole time. And that was really lovely to know that they were actually using our pressure readings and our wind speed readings in a way that helped them kind of inform their decisions. So that's all from me. Hopefully this leaves plenty of time for questions, especially keen to kind of answer any questions people have about sea star platforms, applications they see. Yeah, answer away. Thank you.
Thanks.
That was great. Thank you for that. I think one question I had off the bat as I was thinking about this is what is like your business model? Like, let's say I want to employ a lot of these sensors out in the Atlantic. Am I buying the sea stars and operating them myself, or am I just contracting you as a data as a service kind of system?
Yeah, we do both actually. So for example, the NOAA project is data as a service because it just makes more sense for us to operate them. But a lot of like smaller research organizations, especially those that want to bolt on their own sensors, for them it makes the most sense to buy the sea stars. So essentially, like it does change according to the different customer profile.
Great. And how about those 5 that you had way out there in the Atlantic over the weekend? Did you deploy them, or were they deployed near shore and then controlled out there, or were they taken all the way out there?
Yeah, they were deployed near shore. So they were deployed like 50 miles north of St. Thomas, and then they all sailed forward. So I think one of them sailed like 600 miles to get to her kind of position.
That's an amazing feature to have, to not have to go way offshore to
Yeah.
deploy a system for sure.
I have a silly question. So I think I understand you name them. You usually name all your sea stars. They all have very individual names, but now that you've got constellations of them out there, in terms of like, yeah, how are you keeping track of them? Are you going to be able to use great names?
I'm really sorry. They now just have numbers.
Yep, that's what I thought. Okay.
Yeah, so the one that you guys had, Emperor, was third. Okay. So the generation after that still got names. When it was a batch of 4, they had names. But then the batch of 15 for the Hurricane Sea Stars, they were just called like PC1, 2, PC3, PC4. I think because they were going out into hurricanes, maybe we didn't want to form too much emotional attachment to them. Like we said goodbye and we knew we were probably not going to see those guys again.
Yeah, or gals, right? So one of the things you mentioned was that this last one, they use the data from it to validate their models. Do you have instances where actually your data is coming in and informing, it's like actually informing the models where it's integrated yet, or the process is there?
So the data from this mission is going to GTS, and I think they're still I think so it's being assimilated into some models. So for example, ECMWF, the data is actually being assimilated into that. And it is also available on an ERDAP server for other folks who do want to use it. So if you count data assimilation as kind of helping the models, then yes, it is already doing that. And the ARIA 50 as well should be going into the UK Met Office's kind of forecast model.
So our audience, please don't be shy. If you have any questions you want to pop in the chat or the Q&A, they're both visible, please do. I think the thing that you highlighted too is the valley of death. And I'm not sure, I understand there's several valley of deaths, but I think on the way to us, you would have had maybe other valleys to get across, even just figuring out how to test that or how to find customers, right? I was just curious if you might speak a little bit to that. Yeah, some of the other.
Yeah, good question. Other valleys of death. I think that if we didn't have this, like we have been saved from a valley of death by this ARIA contract. And I think if we didn't have that, we'd also be going through like another valley of death right now. So because we have this contract that's like for 2 years and it's a pretty like good amount of money, we know that we're kind of okay for the next 2 years, and we don't need to therefore raise external investment or like, we can, but we don't need to, and therefore we can kind of focus on scaling up and focus on the technology. Like, we don't have to chase customers no matter what. We can actually focus on really getting the tech good. We can make sure that when we take customer work, we don't like overdo it, so that we can focus on these first customers doing a really good job of it. Whereas if we didn't have that contract, I think we would be in a much more vulnerable position where we'd have two options. Like, option one of like, you must raise like decent amount of investment, and then you've started a stop clock to like give a return on that investment in like, let's say 5 years, which is very difficult for some forms of ocean technology. Or we would have had to like chase contracts and stuff no matter what. And then like, if the sea stars aren't quite ready for like tons of different use cases, that could have been really difficult, So I think like that's another kind of valley of death maybe. And I think, apart from stuff like ARIA, the only solution is maybe customers who are willing to be like early adopters, who are maybe willing to like have like an insane like 50% discount, but they're aware that it's it's still like an evolving product, right? Like, it might still randomly break down after a month at sea, for example.
All right, we've got a couple of questions coming in, so I'm just going to kind of go in no particular order. But the first one that I'm looking at is it's asking about the passive acoustic sensor on the keel, and curious about how much self noise is produced from the boat, and how, have you seen much of it, and how are ways that can be mitigated, or what can you see that's not masked out by the noise of the boat?
Yes, good question. So because it's on the keel, there is noise. Like, the testing with Synchro actually showed this a fair bit. Like, we were able to detect some like humpback whale, I think, noises, but we wouldn't be able to do much more than just say that it's there. So essentially all the keel mounted hydrophone can do is presence absence. You would need to have either the area flooded with sea stars or something like that in order to, say, for example, figure out where they are. And the other thing is, because there's noise, our detection distance is probably also reduced compared to a towing system. But again, it's like you can have 5 sea stars out there instead of one thing that has a 5 times longer detection radius. We are looking at doing a system where essentially the sea star sails out, so same easy kind of deployment thing, and when it gets to a target location, it drops a sensor at depth, and that, for all intents and purposes, moors it in position. So the kind of, there's a lot of drag, that it only uses its final bit of velocity to like counter any currents and just stay broadly in position. And there are kind of 2 sensors that would be used in that configuration, either just like one hydrophone deployed at a certain depth, or essentially like a daisy chain of temperature and conductivity sensors at different depths. And that's actually come from feedback from customers of like, surface freshwater is very nice and interesting, but really it's the water column that holds the most interest. So they would take that data, we would use most likely a machine learning framework to turn that into a 3D model of the entire water column, not just like the 10 readings. And that would be the kind of product that customers would interact with.
Great. That leads kind of the next question, wanting to know more about data management on your end and how you provide data to your customers.
Yes. Sorry, I'm just changing tabs because, like, why don't I just show our tracker? You can access data in 2 different ways. First is via an API, forward kind of way to access data. We are working on expanding that. So via the API, you can directly pull it into buffer format and netcdf format as well, which shouldn't be too hard for us to do. We've got a couple of requests of that. And then during the live mission, you can see the data direct on our dashboard, which is loading. Let me share it. It'll be better at giving you an idea than just me talking about it.
There's a little bit of a
Can you
delay,
guys see that?
Anita. We can't see it yet. We're wondering, yeah, the connection's a little rough. There we go. We've got it.
Okay, so this is the dashboard. here's an example of a sea star out at sea off the coast of Portugal. And here is data coming from it, for example, on wind speed, air temperature, humidity, that sort of thing. So get the data via an API, and you can kind of choose the data format. If you want to kind of direct whilst you're mission managing, you essentially use this dashboard to kind of go around and have a look at the different bits of data.
Okay, I think we're getting a little bit of a lag there, but it sounds like you can save data per mission and then download it off the dashboard. Is that pretty much right on?
I guess two different ways. The first is via an API, and you can choose the data format for the API. And the second is seeing it live on the dashboard.
Okay, very cool. Let's see. Another question is, you've talked about previously the sea stars being the ocean equivalent to small stats. Do you foresee a standardization of payloads for ocean robotics like the space sector has for the CubeSats?
I think that it would be good for the industry if there was. So initiatives such as Bristlemouth, for example, I think are a really great idea. And the more stuff like that, an open connectivity standard can be rolled out, I think it benefits the younger side of the industry, companies like Oshen, for example, instead of existing sensors where you have to be married into a certain sensor family. I do think, however, there is still a long way to go on reducing sensor cost. And some of that comes from an old kind of the kind of previous traditional mentality of if you were taking observations off a ship, you would take those observations so infrequently, you might as well use a really expensive sensor and get great data. But when you have 100 sea stars out there, you maybe don't need each individual sensor to be as high quality because you've got that mass coverage. And I think that is quite a culture shift, and it's just going to take a little bit of time to see that further progress on the low cost sensor side of things to complement the low cost platforms.
You're right. I keep thinking back to a quote someone said a couple of years ago: we need to stop chasing so many data points or so many decimal places. And you know, especially with like temperature, yeah, having it to 2 decimal places is quite adequate in a lot of cases. Yeah, and to talk about a little bit more about Bristlemouth, Synchro now is operating a buoy off of California that has Bristlemouth connectivity, and we can test new Bristlemouth enabled sensors on that system on a real world environment if anyone's interested in that. Just a little Synchro plug there. I think the final question, I know we're at time, but I just want to get one more question in, is powering the onboard systems and new sensors. Do you think there's enough power to be able to support like a little, what's the maximum payload for power do you think you have? Or are there any alternatives to generating more power on board the vessel?
Yeah, I really wish there was a nice, easy answer. The difficulty arises that it very much depends on the location and time of year. So on the Gulf Coast in the middle of the summer, we have so much like surplus power that we could run the thruster like most for half the day, and we could probably run an ADCP if we wanted to. But if you deploy just south of Iceland, or if we're doing a mission up in Sweden or off the coast of Norway, in the winter, then we basically have to conserve power at all costs, and we can't run any additional sensors other than metocean and passive acoustics. If you want to run kind of more in those areas, all you do is you essentially drain the battery, and then you constrain the mission duration. You would have to kind of sail it home every like 3 weeks, for example. So like there are quite hard trade-offs to be considered there. If you're in a sunny location, you have a lot more options.
Sounds like what we need are docking power stations out in the ocean now, so we can hook up to and charge up like our EVs.
Honestly, maybe, or like a little portable sun, you never know.
Yeah.
Oh my
Well,
gosh,
great.
thank you.
Yeah. No, I think that's all the questions we have. I'll give it back to Amy if you want to close us
Oh,
out.
yeah, no, just like a perfect round of questions. Thanks, team audience. Those were all great. This was recorded, and we will be on our website in the next couple days. Probably get a follow-up email. I just want to thank you for the questions. And Anita, I don't know if you've got email there for folks to reach out if they have anything else.
I do, sorry. Why don't I put it up on my screen now? Hang on.
Okay,
So then it's kind of like included in the webinar.
smart.
Well, I'm just going to bring it up in an email because. Okay. Sharing screen again.
There you go.
Okay.
Okay.
So if anyone wants to contact me where my mouse is hovering on the right-hand side, that is my email.
All right, full name. Okay, so again, thank you so much for like being sharing that and showing the story for the first time. And appreciate all of you guys taking 30 minutes of your time today to learn about these awesome vessels. Okay, have a good one. Thanks again.